dear students, here we have another example how to find all the zeros of a polynomial function by using the rational zeros theorem, okay? Now look, the quadratic function in this case is f of x equals 5x to the third plus 9x to the second plus 33x minus 7. Remember, first of all, we are going to check if this is already sorted, so this is x to the third, x to the second, x to the 1, x to the 0. This is already sorted. Now, we are going to write. Remember, the independent term is going to be our p, and the leading coefficient our q. Once we have identified them, we are going to look for the factors of each of them. So, the factors of p, which is minus 7, remember two numbers or that multiply gives me minus 7. It could be positive negative 1 and positive negative 7, because you can multiply minus 1 times 7 or 1 times minus 7, okay, or vice versa. And then the factors for q, and q is 5. So we have positive negative 1 and positive negative 5, because we can multiply 1 times 5 or and that's it, okay, but positive or negative, any of them. Then remember that we have to get the quotient of p divided by q. So we are going to first take the numbers, the factors of p, and we are going to divide them by 1. So we have positive or negative 1 divided by 1, and then comma, positive or negative 7 divided by 1, comma, and then I'm going to divide the two p factors by 5. So we have positive or negative 1 divided by 5 now, and then comma, positive or negative 7 divided by 5. As you can see, here we have, as we have positive or negative, we have 1 and 2, 3, 4, 6, 5, sorry, 1, 2, 3, 4, 5, 6, 7, and 8. 8 possible rational roots, because we have the positive or the negative possibility. Now, again, we are going to evaluate the function in the different possible roots. We are going to start again with positive 1. So we are going to evaluate the original function in 1, when x equals 1, remember. F of 1 equals 5 times 1 to the third plus, and then you continue evaluating in 1. And in this one, we get 40. And remember, if you do not get 0, this is not a root, this is not a 0. So you continue trying with other values here, with other of the rational possible roots. You have to continue, and here I'm not going to continue solving for all of them because of the space, but for example, in this case, I got that one of the roots is 1/5, positive 1/5. So I'm going to evaluate here the function in 1/5, so you can see that it gives us 0. So we have 5 times 1/5, and 1/5 raised to the third. First, remember, don't forget, dear students, that you have to raise this fraction to the third power first, before multiplying, because of the hierarchy of operations, okay? Don't forget. And then plus 9. First you are going to raise 1/5 to the second, and then you multiply by 9. Plus, and then 33 times divided by 5, or times 1/5, minus 7. And that way we get 0. So this is a root. And look now, the degree of this polynomial function is a third degree. That means that we have to get 3 zeros. And once we have gotten one of the zeros, we are doing this. We are dividing x to the third, which is the original degree of the function. We divide it by x, because we are going to divide in this synthetic division by this root. And we are getting now x to the second. And as we are getting x to the second, this is the quadratic function. Okay? Imagine that you have a 5th degree function. So you have to find 3 roots so you can get the quadratic function if the function is a 5th degree, because when you get 3 roots, you are going to be able to get the quadratic root, the quadratic function, and that way you're going to be able to use the general formula to get the other two roots, okay? But in this case, we have a third degree, so once we get one of the roots, while using the rational zeros theorem, we are going to be able to perform here the synthetic division, and then we get the quadratic root, the quadratic equation, and then we continue solving using the general formula, okay? Now, let's continue with the synthetic division. Remember, dear students, I'm going to write here in this little square the root, which is 1/5, the root that we have found, which is 1/5. And then I'm going to write here the coefficients of the original polynomial function. In this case, look, the leading coefficient is 5, so 5. I am going to write here 5. And then the next coefficient is positive 9, and then positive 33, and then negative 7. Okay, that's why this is very important for you to check that you are not missing any x, and that your function is already sorted. Good. In case that you don't have for example, if you don't have x to the second, the x to the second term, you have to write a 0 instead of the x to the second coefficient, okay? In order to get the correct answer. Good. Let's continue, dear students. Now we're going to remember, you write the coefficients here, and then you leave this line in blank. You just leave the space, and then you trace the line, and then we start solving the synthetic division. Remember that we write down this 5, and then we multiply 5 times 1/5. It is 5/5, and it gives, and we get 1. So we are going to write the 1 in the next space, and then we add 9 plus 1, 10. And then again, we are going to multiply 10 times 1/5, and we get 10/5. And 10 divided by 5 is 2. So we are going to write 2 in the next space, and we add 33 plus 2, 35. And then again, we multiply 35 times 1/5, and we get 35 divided by 5, 7, positive 7. So we write it in the next space, and we get negative 7 plus plus 7, so we get 0. And remember, when we get 0 in the remainder, it means that this is a root. Good. Well, once we have solved the synthetic division, we have gotten the coefficients for the next equation, which is in this case the quadratic equation. Because remember, the original one is x to the third. When we divide by this, because remember that here we have x minus 1/5 equals 0. So it is as if we were dividing the original function by x minus 1/5. Okay? Now, you're going to take the coefficients from the synthetic division. So we have here 5 x to the second instead of x to the third. Remember, don't forget. Plus, because this is positive, plus 10x, which is the next x, okay, going down, and then plus 35 equals 0. And look, here we have the quadratic function. Once we have the quadratic function, we are going to get the a, b, and c in order to solve our, to get the other two roots while using the general formula. So a equals 5, b equals 10, and c equals 35. Okay? Now, check, dear students. We have x equals minus 10, which is b, minus b, remember, plus minus the square root of b to the second, which is 10 to the second, minus 4 times a times c, times a, which is 5, times c, which is 35, divided by 2a. So we have 2 times 5. We solve it, so we have minus 10 plus minus the square root of, and all these calculations gives me minus 600 over 10. And careful, dear students, because look, this is important. When the discriminant is negative, remember that we are going to get a complex number root. So, check. Here we are going to write minus 10 plus minus, and remember that in order to get the complex number, we separate the positive and the negative roots. So we have positive square root of positive 600 times the square root of minus 1. And remember, because of the theorem, that the square root of minus 1 equals I. So we're going to get, when we simplify this square root of 600, we get 10 square root of 6, okay, which is the positive part. And then the square root of minus 1 equals I. So careful, this is important for you to remember how to get the complex numbers. Now, we have minus 10 plus or minus 10 square root of 6, I. Remember that the I, the letter I, is outside the root. Do not write it inside the root. This is not inside the root, okay? Careful. Over 10. Good. And then as you can see, look, we have minus 10 plus or minus 10 divided by 10. So all of them are 10. So we can cancel out of 10. We are going to divide this 10 by 10, this 10 by 10, and this 10 by 10. So we get minus 1 plus or minus square root of 6i. And then we're going to be able to write the three roots that we have gotten. So the first one is x equals minus 1 plus square root of 6i with the plus sign. And then the next one, minus 1 minus square root of 6i. And the third one, which is the one that we have gotten here, is x equals 1/5. And here, dear students, you have the three roots of this polynomial function. Good, dear students. As you can see, this is not so hard. You just have to practice and study hard because this is important for you during whole your life. Don't think that maths are not going to be useful for you. They are. Indeed, they are. So take care, continue studying hard, and stay at home, and see you later. Bye.